Hi, I am the team captain of Raclab team from Technical University. This is our flight readiness review video and it will start with introducing our team members.
I am Uğurcan Hoşsöz. I attended competitions as a software developer for three years in Raclab team. In this competition, I am responsible of designing obstacle avoidance algorithm and the team communication. I will be the flight leader at Flightline. Furkan Mumcu is part of Raclab team for 2 years. He has experience with UAV design. In this competition, he is responsible of UGV design and antenna tracker design. In Flightline, he will be the antenna operator. Hasan Uğuz is part of Raclab team for 3 years. He has experiences with autonomous flight, UAV subsystems. In this competition, he is responsible of developing software and system integration and testing. In Flightline, he will be the GCS operator. Muratan Mert is part of Raclab team for 2 years. He has experience with UAV design. In this competition, he is responsible of UAV design and drop mechanism design. In Flightline, he will be responsible with ground spot. Mustafa Ünlü is part of Raclab team for 2 years. He has experiences with software development and image processing. In this competition, he is responsible of developing object detection, classification and localization. In Flightline, he will be the manual ODCL operator. Kadir Berk Demirci is part of Raclab team for 2 years. He has experiences with autonomous flight and ground vehicles. In this competition, he is responsible of UGV design and electronic components of drop mechanism. In Flightline, he will be the autonomous ground vehicle operator. Eyüp Ekinci is part of Raclab team for 2 years. He has experiences with software development and autonomous UAV controls. In this competition, he is responsible of autonomous flight and antenna tracker. In Flightline, he will be the co-pilot. Onur Demircan is part of Raclab team for 3 years. He has experiences with autonomous flight, ground control station and being a pilot. In this competition, he is responsible of ground control station software. In Flightline, he will be the pilot. as XS form in order to prevent any crash in case of engine failure. Electronic components of UAV were chosen carefully to create stable system. GPS here model has 2 meters circular error ratio, which increases our waypoint accuracy. ARM-based Pixar 2 was chosen as flight controller because of its features and price. NVIDIA Jetson model is used for programming the UAV. It was chosen for its high processing speed. Pilot model establishes communication with antenna in 5.8 GHz band. Motors were chosen to provide required thrust for pre-calculated weight of UAS. After the motor selection, electric speed controllers was chosen by motor type. -1045 carbon fiber propellers used in our UAS. Radio link receivers, which works at 2.4 GHz band, is used for communication with radio controllers. Obstacle avoidance algorithm was achieved by mathematical approach. Two-dimensional calculations preferred instead of three-dimensional because of its simplicity. Approach of Sherbrooke University inspired us to solve obstacle avoidance problem. Same algorithm with Sherwood University is tested for our systems, and in order to reduce energy consumption, new method was developed. In new method, instead of creating many waypoints, only one or two waypoints around the circle was created with calculation of tangent lines. With this approach, we managed to increase our linearity during the flight. Object detection and classification was done by TensorFlow API, which uses deep learning method. Required amount of data gathered by various methods and big scale of train data was gathered. These data used to train different types of algorithms, and the best method with the accuracy was chosen. For color classification, histogram analysis was used. First test showed us the image quality was insufficient. Therefore, a better camera with 4K resolution was chosen to improve image quality. Thus, image quality increased from 8 pixels square to about 32 pixels square. When we inspect our flights, we detected problems with waypoint accuracy. In order to reduce error in waypoint accuracy, UAV programmed to decelerate when approaching to a waypoint. Integration of all softwares completed and full system tests conducted. According to these test flights, we expect 2-meter error in waypoint accuracy, 60% success in autonomous object detection, classification and localization, 100% success in obstacle avoidance, and 40% success in airdrop missions.